Hello students, welcome back to my channel. Today we will study the topics of jam group theory, that is, we will discuss some questions related to conjugacy class and class equations. Now let's get started. We have studied two methods to partition a group. First is by forming cosets which have equal distribution as order of H is equal to order of HB equal to order of H, and in this second is conjugate classes which has unequal distribution. Which of the following can be class equation of a group of a given order? 10 is equal to 2 plus 2 plus 2 plus 2. 10 is equal to 1 plus 1 plus 1 plus 2 plus 5. 10 is equal to 1 plus 1 plus 2 plus 2 plus 2 plus 2. 10 is equal to 1 plus 1 plus 1 plus 1 plus 5. Here it is plus 2 and here it is one more 1. So now इसको देखने के लिए first one is false because there is no element in center, while center has at least one element, that is the identity. Now in second case center of G का order 3 है because there are 3 conjugacy classes of order 1, but 3 does not divide the order of group, as center of G is normal subgroup of G, and by Lagrange's theorem it should divide the order of group, and hence this is also not the case. In this case center of G का order 2 है and 2 divides 10. Now we'll see G by center of G का order, that is 5, which is prime, which in turn implies G is abelian, which is not the case here because there are only 2 elements in center of G, not the whole of the group. Now in fourth case, we have center of G का order is 5, which divides 10. G by center of G is 2, which is again prime, and the same conclusion holds. Therefore, this is also not the case. Now, another example is 4 is equal to 1 plus 1 plus 2. 4 is equal to 1 plus 1 plus 1 plus 1. 4 is equal to 8 is equal to 1 plus 1 plus 3 plus 3. 17 is equal to 1 plus 1 plus 1. 17 times. Now let's see. 4 is equal to 1 plus 1 plus 2 is center of G. Order is 2, which divides 4. Now next step would be order देखना, which is 2, which is prime, and hence we arrive to this conclusion that G is abelian, which is not the case here. Therefore it cannot be the class equation. This can be a class equation for G equal to Z4, which is an abelian group, and similarly this can also be for G equal to Z17, which is also an abelian group. This cannot be the case. Why? Because center of G का order is 2 and G by center of G का order is 8 by 2, that is 4. इससे हमें कोई information नहीं मिली because 4 is not prime. Now we know that conjugacy class of A का order should divide the order of G, but here this conjugacy class का order 3 है and 3 doesn't divide 8. Therefore it is not the class equation. Now if G is a group basically a P group of order e raised to power n, then center of G order is greater than 1. Proof: by class equation we know P raised to power n equal to order of G is equal to order of center of G plus summation order of G over centralizer of A for A belonging not belonging to center of G. Therefore, it implies P raised to power n is equal to order of center of G plus summation P raised to power n over P raised to power m as centralizer of P divides order of G. Therefore, it is in some power of P, which in turn implies center of G का order is summation P raised to power n minus m. That is center of G order is equal to P raised to power n minus P raised to power n minus m summation. That is P divides center of G order, and therefore order of centers of G is greater than 1. Next result which we are going to do is every group of order prime square is abelian by considering order of center of G. Order of center of G divides order of G, that is order of center of G can be 1 P of P square. 1 it cannot be because it is a P group, therefore center of G is greater than 1 as we have done earlier. If it is P, then G by center of G is equal to of order P square by P, that is P of prime, therefore G is abelian. Now if center of G order is equal to P square, it implies G is equal to center of G and hence G is abelian. Let G be a group of order PQ where G is non-abelian, then center of G for order is P. Proof: center of G order divides center or order of G. Therefore, center of G has choices 1 P, P square or PQ. If its center of G order is 1, it cannot be because it is a P group. Therefore, center of G order is greater than 1. And if it is PQ, it implies center of G is equal to G and hence G is abelian. This is not so since G is non-abelian. And if it is of order P square, then G by center of G order is P of prime. Therefore, G is abelian, which is not so. And hence, the only choice we have left is with center of G is of order P. Which of the following can be the class equation? First, 125 is equal to 1 plus a1 and so on plus ak such that all ai's are greater than 1 for all I. Second, 10 is equal to 1 plus 2 plus 2 plus 5. Third, order of j is equal to 1 plus 1 plus 1 k times plus a1 plus ak for all ai greater than 1. Now in first case, since it is p cube, that is 5 cube, therefore order of center of G is p, that is 5, but here we have only 1. therefore it cannot be the case. Also, it is a P group, therefore center of G chord is greater than 1. Second, center of G chord is 1, can be possible. And conjugacy class case size also divides the order of group, therefore it can be possible. And in this case, center of G, the order is K, and order of G, the center of G, or order is where it is given, already given in the question that order of G by K is prime. Therefore is prime, that is G is abelian, and hence this cannot be the class equation, therefore this is the only choice we have left. Now let's discuss about some of the class equations of important groups. For A4, 1 plus 4 plus 4 plus 3, A5, 1 plus 12 plus 12 plus 20 plus 15, D3, 1 plus 2 plus 3, D4, 1 plus 1 plus 2 plus 2 plus 2. You can also use the formula which I have given for Dn groups. D5, 1 plus 2 plus 2 plus 5, Q8, quaternion, 1 plus 1 plus 2 plus 2 plus 2. Order of centralizer of sigma, where sigma is a permutation in Sn having Ni cycles of length Li. Order would be product I Ni factorial product Li raised to power Ni